Alright, so here's the thing. Colors do not exist. It's a mind-bending idea to wrap your head around, but colors are truly in the eye of the beholder. Leaves, for example, aren't green. It's our own perception of them that makes them green. Yet the question in the title does have an answer. We can measure the color of an atom. First, though, we must ask a more fundamental question. What is light? Well, you can think of it as pure energy cruising the universe as waves. As with all waves, the more energy they carry, the higher their frequency. But you can also think of light as made up of tiny massless particles called photons. This is what we call wave-particle duality. It doesn't mean that light is two things at the same time, both a wave and a particle. Light is light. What it means is that both are solid theories, but there are behaviors light has only one or the other can explain. We need two different ideas in order to be able to wrap our heads around this incredible phenomenon called light. You can imagine a photon a bit like a boat, small, self-contained, riding a wave of its own making. And just like a boat, a photon travels at sea. C, the speed of light in a vacuum, the top speed in the universe. Light is part of the electromagnetic spectrum of frequencies. Of this wide range of choices, our eyes only perceive a tiny sliver. Our brain interprets the different frequencies as colors, and when they're all mixed up, we see white. When a photon meets a substance, it is absorbed if it has the right frequency, but else is reflected. We know, for instance, that gold reflects yellow. Another more interesting example is glass. While transparent to visible light, it reflects the more energetic ultraviolet light and is therefore opaque to it. Because each atom or molecule has its own signature frequencies it reflects, we can recognize what we're dealing with simply by this light fingerprint. It's called the emission spectrum of that substance, and here are a few. Atoms have, in a sense, color, which we can't perceive or imagine, but we can measure it. By this method called spectroscopy, we find out what distant planets and stars are made of. Or rather, what they were made of millennia ago. You see, because light emitted by these faraway bodies is only reaching us now, after thousands or even millions of years, we can only gaze into the past. What we see in the night sky is what the universe used to be. Yet it's awesome to think we've worked all this out among many more in only a few centuries of hard science. Not bad for a few cheeky monkeys hurtling through the universe on a damp rock. Not bad at all.